B.2 graphs of asymptotic notations. So in this part, we try to get a visual understanding on asymptotic notations. All right. Because usually these asymptotic notations relatively hard to understand, pretty abstract. So if we try to use from the graphs of the functions, we get some visual understanding, the relationship between two functions, then it helps us to get a better idea. All right, the first example, big O notation. So we just learned the last time, the big O notation. Okay? From the graph, what's that? We know the big O notation, it means we can find a constant C, right? So f of n less than or equal to C times g of n, right? Yeah. But that inequality only true when n greater or equal to n0, right? For some pre-selected n0 number. Before that, you see it doesn't matter, right? Yeah, so we treat that, the overhead part. Yeah, it doesn't matter. We don't look at that. Okay? Which one faster or higher, lower? Not important. Yeah, we only look at after one particular line. After that line, everything counts. Okay, before that line, nothing counts. After that line, everything, every point counts. Okay, yeah. Then this C multiple of G bounded above, or bound, control. Yeah, let's say this. Control f function, f of n from the above. From its above, above it. Above, on top of it. So you can see this is the graph representation of big O notation. Yeah. All right, so let's look at some other asymptotic notations and their meaning, definitions, and graphic representations. Yeah. The second one, big omega notation. So we learned the little omega notation, right? So that limit, infinity, right? That little, yeah. So here, big O, so here you can see we have big O notation and the little o notation, right? Little o notation corresponds to the limit f of n over g of n equals 0, okay? So for that case, here we do not, because we use the limit to represent the meaning. So here we do not use the upper bound, lower bound. Okay, so little o, we do not use upper bound, lower bound. All right. Similarly, for big omega, here we have a big omega case. Yeah. So here, let me describe the situation. Yeah. Big omega, and we have a little omega situation before, right? Yeah. We learned in the previous video. Little omega, that's the limit infinity, right? F of n over g of n, limit infinity. So we use the limit way to describe this notation. So we do not use upper bound, lower bound. Okay? In these two cases, we do not use upper bound, lower bound. We just use limit way. Yeah. Now, big O and big omega, now we use the upper bound, lower bound way. Because the limit way, cannot give us the complete description of these two cases. Complete description, only partial description. Okay? Partially correct, but there is another part not correct. So that's why we do not use the limit way. Okay? For big O, big omega, we need to use the upper bound, lower bound way to describe it. Yeah. So now you can see our big omega notation, the meaning. There exists some positive constant C, still the same thing, and 0 such that lower bound. This time we control f of n from the lower side with C multiple of G function, right, for all n greater or equal to 0. So that same overhead part. So you can see, you can look at big omega together. One the upper bound, one the lower bound. Right? If you want to use a graph, you can use the similar graph, but this time you bound it below. Okay? You bound the f function from below with constant multiple of G function. The last one, the last asymptotic notation we want to learn, big theta. So in our B.1 video, we learned that case number 2, the limit is C. That one, we use the big theta notation, right? And I said I want to extend it to cover more cases. Here, we use upper bound, lower bound way, so we can cover more cases than the limit way. All right, big theta notation. The condition part, the description part, pretty much the same. Here we use the new notation, big theta notation. Now the condition part. We need to get 2 positive integers, C1, C2. Here's, also, we also need that n0. Then, when we try to control the original function f of n, we control from both upper bound side and the lower bound side for all n greater or equal to 0, n0. So you can see, actually, we combine the conditions from big omega and big O. So if a function satisfies both conditions, then we get big omega, big theta. We get big theta notation. If you want to look at it from the graph, then it's easy. So f1 function, you use a multiple of G function, control above, multiple of another multiple of G function, control from below. One from above, one from below. Okay? So now, big theta. Big theta means these two functions has the same order of growth. Same order of growth. Okay? Control above, control below. Okay? That's the relationship. Okay? All right. So at this point, I gave you explicit meaning of the asymptotic notations we will use for this class. For this class, we just use these asymptotic notations. Okay? These asymptotic notations. For the remaining of this class, we will, whenever we have the right situation, we will use these asymptotic notations. All right, so I finished this video, but in my next video, I want to give you several examples. So we try to do some calculations on those examples, mainly we do the limit. Okay, mainly we calculate the limits. Yeah, do calculations. Yeah, and we try to get a little better understanding on the asymptotic notations. All right, so yeah, we are complete this one.